The last section in this polar equation section is going back and forth from polar to rectangular. So the other one, you started with x and y's, went to r and thetas, and the idea was you just wanted to get the equation to r equals something. Now though, we want to get this to x and y's. But the question is, what is going to be my final answer? It's not as easy as just saying, you know what, I'm going to plug in x equals r cosine theta, y equals r sine theta, and simplify. This one we've got to be a little more thoughtful about, I guess you could say. We just want to come up with some different ways to do this. So the first thing we want to look at is what is going to be simplest form. So simplest form. And that's when you can say, I'm done. And there's really 3 times you can say it. The first time would be if you get it to y equals everything else. That's what you've done for many years with y equals mx plus b, or y equals ax squared plus bx plus c. Get everything into a y equals form. That's one way to do it. The second way would have everything equal to 0. Everything is equal to 0. So x squared plus y squared minus 6x plus 2y plus 5 is equal to 0. Get everything equal to 0. The third way would be if you have a known equation. For example, something that's in a circle format or a parabola format. That would be something that you could put in just as a known equation and leave it as is. X squared plus y squared is equal to 17. That you know is a circle with a radius of the square root of 17, so you could just leave that in that form. So with these, we are going to need to be thinking backwards. We're going to be thinking of tangent inverses, and we're going to be thinking of x squared plus y squared is equal to r squared. So in the first one right here, I see an r and a cosine of theta. It would be really nice if this was an r cosine of theta, because we know r cosine of theta is the same thing as x. So let's start by multiplying through by an r. So if I start by multiplying through by an r squared is equal to 5r cosine theta. And when I did that, I actually did 2 things. We know r cosine of theta is the same thing as x, but we also know that r squared is the same thing as x squared plus y squared. So x squared plus y squared is equal to 5x. Let's move our 5x to the other side. And our equation is equal to 0, so we can say we're done with that. The second one, we're given a theta by itself. This is a prime time to take a tangent to both sides. So here, theta, let's take the tangent to both sides. The tangent of theta is equal to the tangent of 5 pi over 3. We know that if we take the tangent inverse, it's going to be the same thing as y over x. So tangent of 5 pi over 3 we know is negative square root of 3. That one's on the unit circle. And we know the tangent of theta, by definition, is the same thing as x. Actually, it's y over x. So tangent of theta is the same thing as y over x. So now to solve, to get in one of these 3 forms, we could put it in y equals form by multiplying both sides by x. Third example we have here is very similar. We can take the tangent to both sides. We know the tangent of 7 pi over 4 is equal to negative 1. We know the tangent of theta in terms of rectangular coordinates is y over x. So now I can solve by y for y by multiplying both sides by x. In letter D, we got r equals 15. I could try multiplying through by r and then get r squared is equal to 15r. But that 15r really doesn't help me because I don't have a cosine of theta or a sine theta in there. So there's nothing else I can substitute in. So let's square both sides. R squared is equal to 225. We know then R squared is the same thing as X squared plus Y squared, which is equal to 225. And if I wanted to, I could simplify for Y or move the 225 to the other side. But this is a known equation. That is a circle with a radius equal to 0.